Continuing with section 3.5, we're going to be looking at growth models. First up, they're very similar to our position, velocity, and acceleration problems. If I'm going to compute the average, I would just compute the slope of that secant line between whatever 2 points that I'm talking about. We've been given the function of how this growth is occurring, and this growth happens to be internet users. The growth can be anything from population of bugs and people, bacteria. It can be something that can be something like carbon decay. The list goes on and on about the natural occurrences of how things grow or decay, and growth and decay are basically the same model. So we've been given a function that relates the number of internet users between 1995 and 2010. So this year happens to be 1995. This one would be 1997. This would be 1999. Let's see. Then this would be 2001, 2003, and 2005. Helps me sometimes just to put these on here. 2005. Then that would be 2007, 9, and 2011. All right. They want me to do the average growth rate from 2000, which is right here at t equal 5, to t equal 10, which would be right here. So I need this dot and I need this dot. I need to know those y values. So let's go get them. I need to know f of 10 and I need to know f of 5 for this A problem. F of 10, I just plug in a 10, 3 times 10 squared plus, of course I could put it in my calculator in the graphing part and then just have it compute the value, which is what I do sometimes if I'm going to be messing with this quite a bit. So, and then I'm going to plug in a 5 here and then crunch those values. So I went and got those values for you. Now we're supposed to write average growth. So I'm going to do f of 10 minus f of 5. It's just difference in the y's over the difference in the x's. 10 minus 5. And I would just plug in 962 minus 383 all over 5. And when you crunch those numbers, you'll get about 116 million per year. What is the instantaneous growth rate in 2006? Instantaneous growth rate means I need the derivative. The average is just finding that slope. Instantaneous means find that derivative, so this would be 6t plus 70.8. They want 2006, so 2006 would be, I need to figure out what that t is. So 2006 minus 1995 is 11. So I'm going to plug in an 11. P of 11 is 6 times 11 plus 70.8. And that is going to be, crunching those numbers, 137 million a year. C. The C question just asks us to plot this 6t plus 70.8. Of course, that's a linear function. Here it is. It's sitting here. this is the P prime of T equals 6T plus 70.8. What can be said about it? The growth rate is increasing. You can say the growth rate is positive. So I know that that growth rate is going up. So I'll just say increasing and positive. You could say that's going up in a linear fashion. Assuming that the growth function can be extended, what is it? Predicted number of users at t equal 20. So at t equal 20, I'm just plugging into my growth function because I just want to know what that number is. So I just want to know what P of 20 is, and then I crunch those values, and you should get about 2570 million users. The next set of word problems has to do with average and marginal cost. This first graph, we're given a cost function, and this is the cost to produce so many items. This next function wants to know what's the average cost per item. So what you'll do is you'll divide by however many items you happen to produce. So let's say that you produced 8,000 items, then you would take and divide everything through by that 8,000 to get how much it costs per unit. The marginal cost is how much it would cost to produce whatever it was that you did plus one more additional item. So the average cost tends to talk about what happened in the past, and then the marginal cost is what do we predict will happen in the future. And that's the difference between those two. And the marginal cost is to just take that cost value and take its derivative. So it's like that instantaneous. In the first question, they have asked me to find the average and the marginal cost functions. So let's do our A part here. We want the average cost. So I'm going to take my C function, or my cost function, and divide it by however many units I produce. So for this particular case, we have negative 0.02x squared plus 50x plus 100. Each one of these gets divided by x, and writing them out one at a time, I get that. That's the average cost. The marginal cost function is C prime. So I'm just going to take my cost function and take the derivative of it, negative 0.04x plus 50. The B part wants to know the average, okay, and tell what these values mean. Average cost at 100, just plug in 100 for x, and then crunch those numbers. So I'll write down what it is, and then we'll crunch. When you crunch these numbers, you'll find that the average cost of producing 100 items is $49 an item. The marginal cost is the cost of producing that 101st item. So that would only be $46, which lets me know that to produce one extra item after I've already produced that 100 items is going to be less than it was for each of those individual items ahead of time. And we're going to do the same exact thing for 900. So I've plugged these numbers in for the 900 and crunched the values. So it's going to cost me $32 per item to produce 900 items. But to produce that 901st item, it will only cost me $14 per item. And the point they were wanting to drive home here is when these values go up, what a big difference that it makes in your answers. And I believe that's all for section 3.5. Let me know if you have any questions about these.